Right, in 11.5, we're going to be looking at other types of equations besides quadratics. That might be kind of written in the form of a quadratic, but they're not actually an x squared. But we can solve them using similar techniques like we did a quadratic, where we can factor or square root, stuff like that. Let me show you. If you look over here at the left, we have a quadratic. Those are problems that we're used to solving. We have an x squared, we have an x term, we have an 8 over there without a variable, we have a trinomial set equal to 0. We know that we can solve quadratics a couple of different ways. We can factor, we can try to complete the square, or we can use quadratic formula. On this one, I'm going to try to factor first. That's like reverse foiling, remember? I can try to break up that x squared into two separate parentheses, and then figure out what numbers multiply to 8, that when I add them together I get -9. I ended up getting x minus 8 and x minus 1. If you were to FOIL that out, multiply, combine like terms, you would end up getting that quadratic, x squared minus 9x plus 8. Now I can use this to help me solve, because now that I have two factors and they're set equal to 0, I can set each of those factors equal to 0 and solve. We've done this a lot in the past. So I can say x equals 8 and x equals 1. Remember that we knew we had two answers because we had a quadratic. Our highest degree was 2, so I should have two solutions. So look over here to the right. This one looks similar to the one we just did, but instead of being a quadratic, it's now an x to the fourth. It has a fourth degree polynomial, but it looks like the same type of form, just my exponents are a little bit bigger. So because it has that same kind of quadratic form, what we can try to do is still solve it just like we did when it was an x squared. We can try to factor it, but instead of an x squared and breaking it down into x and x, we can take that x to the fourth and break it down into an x squared and an x squared. If you were to FOIL it, x squared times x squared is x to the fourth, x squared times -1 is -1x squared, -8 times x squared is -8x squared, and those would combine into a -9x squared in the middle. And then -8 times -1 is a +8. So I can kind of factor it, factor it, just like I did before, but now I have an x squared instead of just a regular x. But now that I have two factors set equal to 0, I should be able to continue solving by setting those factors equal to 0, just like we've done in the past. So I can take my x squared minus 8 and set it equal to 0, and my x squared minus 1 and set it equal to 0. You notice that both of these small blue equations just have an x squared. There's no x term, there's just an x squared. So I can go ahead and isolate that x by adding 8 to both sides and square rooting in order to get x by itself. Now be careful. Remember, anytime you square root, you need to make sure that you add that plus or minus. And instead of saying the square root of 8, I can break that down into 2 rad 2. So I actually get two answers for that piece. I get x equals +2 rad 2 and -2 rad 2. Over on the other piece, I'm going to add 1 to both sides. I'm going to square root to get rid of the square. And I ended up getting x equals ±1. How many answers is that? Well, you notice that we actually get 4 answers. And if you look back at the original problem, it's to the 4th degree. So I knew that when it was an x squared, I was going to have 2 answers. Now that it's an x to the 4th, I need to make sure that I have all 4 solutions. So that's a quick, easy way to make sure that you didn't forget your plus or minus, because you should have 4 solutions. Let's do another one. If you look at example number 1 with me, it kind of looks like the one we just did. We have an x to the 4th, we have an x squared as my middle term, and then I have a +16. It looks like a quadratic, but it's really x to the 4th. But it's kind of in that same form, right? So what we can try to do is factor just like we did before. Now, if factoring doesn't work, we might need to use a different technique, but let's always try to factor. All right, I can go ahead and break this x to the 4th down into an x squared and an x squared. I need to figure out what numbers multiply to +16, that when I add them together I get -17, and you should end up getting an x squared minus 16 and an x squared minus 1. Now that I have two factors set equal to 0, I can set each piece equal to 0, and then I can continue solving by isolating that x. I can add 16 to both sides, I can add 1 to both sides, I can square root using my principles of square roots. The square and the square root cancel. Remember that we're supposed to have 4 solutions here, so as soon as I square root that 16, I end up getting x equals plus and minus 4, and when I square root 1, I end up getting x equals plus or minus 1. I have 4 solutions to this equation That's to the fourth degree. So kind of using our techniques that we did when they were quadratics, even though they're not quadratics, factoring and then solving from there.